Let's start with the subtopic 4.2 that talks about weight and drag force. Here, going to this question, if a person is in equilibrium, so this means that the net force is zero. It gives an indication once we see word equilibrium, so automatically net force without thinking is zero. Now, going to question 11. When a person is in an elevator, so we have the cases of elevator. If the elevator is accelerating upward, so in this case, we're gonna have that the apparent weight is gonna be greater than, more than the actual weight. For example, if the weight of the person is, let's consider 600 newtons, then while standing on a scale, if it becomes 700 newtons, this means that the elevator is accelerating upward. But if it changes from 600 newton to be, let's consider 400 newtons, this means that the elevator is accelerating downward. The case of having both of them equal, and if the actual weight and apparent weight are equal, so we have two cases. Either the object is at rest or moves with constant acceleration. Let me just show you here, just to remind you the cases of elevator. If you do remember, here, these are the cases. So, just a quick reminder. If the apparent weight and actual weight, the apparent weight and actual weight are equal, this means either the object is at rest, this means no motion, يعني zero acceleration, أو الobject might move with constant speed, كمان acceleration is going to be equal to zero. While if the apparent weight is greater, more than the actual weight, here in this case the elevator will be accelerating upward. While if the apparent weight is less than the actual weight, this means that it moves downward, and of course we call this weightlessness. And the weightlessness, this known as weightlessness, this, when the wire breaks. So going to the question here, when a person is in an elevator that is accelerating upward, this is the keyword. So automatically what happens to the apparent weight? The apparent weight increases. So apparent weight becomes more, so it increases because it moves upward. Going to next question, what is a drag force? It's a definition. Drag force is always can be described as a force that opposes motion through a fluid, which is, a fluid could be either liquid or gas. Sorry. liquid or gas. Okay, going to next part. So the definition is A. Here the diagram shows different letters, and each letter is representing a specific force. Of course, here in case of parachuters, what is J? J, which is the downward force, automatically is the gravitational force. And the K, that is the upward, could be air resistance. We could call it as air resistance or drag force. The option here is air resistance. So we're going to air resistance. When the skydiver jumps from the aircraft force, J is what compared to K? So at the beginning of the motion, J is greater. Going back again, just to remind you here, for the skydivers, at the beginning of the motion, a gravitational force is greater than, we don't have air resistance or drag force yet. After a while, air resistance will start increasing, but still smaller than the weight. At the moment when air resistance or drag force becomes equal to the weight or gravitational force, in this case the skydiver moves with a constant speed. We call it as terminal velocity. We call it as a terminal velocity. So when exactly do we have a terminal velocity? When the air resistance is equal to the weight. So going back to the question here, so when the skydiver jumps from the aircraft, so J, which is the weight, is always greater than K. When the skydiver jumps from the aircraft, the skydiver, of course, since J is greater, so it will be accelerating downward. It makes sense.